Hi, welcome back. It's Professor Ridge, and today's lesson 5.2, multiplication of polynomials. So basically we're going to go through all the different types of polynomials. So we'll start out the easiest, monomial with monomial. So to multiply monomials, you just multiply the coefficients, the numbers in front, and use exponent rules for the variables. So let's do an example. So if I wanted to do like 4x squared y times, so that's a monomial, times 3x y to the fourth z. So I always say in my classes, you're going to do numbers, letters, and then do alphabetical order too for letters, just to help make a system. And the reason it works is because this is all multiplying, so technically we can rearrange the orders because of commutative law. So we can switch in orders, no big deal. And it's associative, so we can drop the parentheses, rearrange it because of commutative, and then regroup it however we want. So we've got a lot of freedom because it's all multiplying. And that's what allows us to work. So basically I'm going to lump the numbers together, the letters together. So numbers, letters, numbers, letters. So I do the 4 times 3, and of course I would never write that down. I do 4 times 3 is 12, other than for your notes. So 4 times 3 is 12 numbers. Then I'm going to do the letters using exponent rules. The base is the same. You leave the base alone, add the exponents. Y times y to the fourth is y to the fifth, and then z. Okay, so numbers, letters, numbers, letters. So we'll try a few exercises from the exercise set. Number 10, so again the numbers, so negative 2 times 4 is negative 8. Then the letters using exponent rules, the variables, so 3 plus 1 is 4. And that is the final answer there. Let's try number 14. We have negative 7a squared b c to the fourth times negative 8a b cubed c squared. And again, numbers, letters. So I do the numbers. Positive 56 a to the third, because 2 plus 1 is 3. B's, b1, b3, 1 plus 3 is 4. And C's, 4 plus 2 is 6. So simple enough. Alright, so that's a monomial with a monomial. Now moving to monomial with a binomial, or I should say with a polynomial. So to multiply a monomial with a polynomial, you're going to use the distributive property, and then you just multiply the monomial with each term in the polynomial. So let's look at an example. So if I had 3x squared times 4x cubed plus 2x squared minus 7x plus 1, you take that 3x squared, distribute it to each term, to 3x squared times 4x cubed, and again you wouldn't write that, you would just write the answer. 3x squared times 2x squared, 3x squared times negative 7x, 3x squared times 1. And you would get, remember, numbers, letters, numbers, letters. So we get 12x to the fifth plus, then the next term, 3 times 2 is 6, x to the fourth, 3 times negative 7 is negative 21, x to the third, and then for the last term, 3 times 1, it's just 3x squared. And there you go. Alright, so now a little more general, if I want to multiply any two polynomials, so 2 terms, 2 terms, 3 terms with 2 terms, 5 terms with 5 terms, doesn't matter, any two polynomials, we're just going to use this distributive law again, and you're going to multiply each term in the first polynomial with each term in the second polynomial. So let's look at an example. So if I had 3x squared minus 4x plus 2 times x squared plus 3, we'll do 8x, plus 7. I'm going to start with the first term, distribute it. So we're going to get, and again, normally I wouldn't write this out. I would just write the answer. So 3x times each of them, 3x squared, sorry, times each of them. Okay, so the first term's done. Now I go to the second term, negative 4x, and distribute it with each term in the second parenthesis. And I should have wrote a lot smaller. Okay, so then I'm going to distribute the 2 with each term. Okay, so now that I've distributed with each term, again, I wouldn't write that down. I just write the answer of each of those. So this is the step where I would start. So 3x squared times x squared is 6x to the 4th plus 3x squared times 8x, 24x cubed. 3x squared times 7, so that's plus 21x squared. And I'm going to go to the second term, distribute it. So negative 4x times x squared, negative 4x cubed. Oh, I messed up on my very first term. 3x squared times x squared is just 3x to the 4th. Let me just double check here. 24, 21, okay. Negative 4x cubed. Okay, so I'm on the second term. Negative 4x times x squared is negative 4x cubed. Negative 4x times 8x, negative 32x squared. Then the next term be negative 28x. Alright, so that completes the second term. Now I go in the first parenthesis. Then I go to the third term in the first parenthesis, which is the 2. Distribute it. So I get 2x squared plus 16x plus 14. And now I'm going to combine all my like terms, do descending order, 3x to the 4th, I'm going to do x cubed. So I got 24 minus 4 is plus 20. Then I do my x squares, x squares, x squares. So let's see, I got 21 minus 32 plus 2. That is 9, negative 9 x squared. And then, let's see, I'm at x squared, so now x's, see descending order. So now I'm going to do x's, so I got negative 28, positive 16, and that is negative 12. And then constants, just this number, so plus 14. And that's the product of those two polynomials. Now, of course, if we have a special one for just two terms with two terms, and I can hear you saying FOIL right now, so let's cover that. Okay, so the FOIL method, it's strictly for two binomials, a binomial times a binomial. So FOIL, so it stands for first terms, it's the F, first terms, outside terms, inside terms, and last, F-O-I-L, FOIL. So if we have two terms, say A plus B times C plus B. So your first terms would be the A times C. Your outside terms would be your A times D. Your inside terms would be B times C. And your last terms would be B times D. And you can see that it's just the same thing as the distributive property. It's just an acronym to help trigger your memory if you forget. Personally, I like to try to get you to stop thinking FOIL method and just think, let's distribute. Take the first term, distribute it, go to the second term, distribute it, so on. And then that's just more general anyway. But this is kind of a remnant that everybody learns FOIL, so it's still around. Alright, let's go on to the next topic. Okay, so squaring a binomial. If I asked you to do A plus B squared, and I had you do it the long way, using FOIL, or distributive property, you're going to do A times A, which is A squared, A times B. Okay, now you go to the second term, distribute it, B times A, which is still AB, and B times B, that's B squared. Combine like terms, you get 2AB. Now, squaring is something we do a lot of in math. So the idea then is we skip all the work and memorize this pattern. So you memorize this pattern, make it a shortcut. So I think it was a pattern. A is your first term, B is your second term. So if I asked you to multiply or square 3x plus 5, you're going to take the first term, which is 3x, square it, take 2 times the first term times the second term, plus, and then the second term squared. So remember, A is first term, B is second term. So again, you wouldn't write it down. The whole point is you learn to do this quickly. So this will be 9x squared, 3x times 3x. And then I usually do the number, because it's multiplying, I can do it whatever order I want. So normally I multiply them together first, which is 15x, and then I double it, so that's 30x. And then 5 times 5 is 25. So that's squaring a binomial. And then if you were to change the sign to a minus, let me squeeze that in here. The only thing that changes is that middle term becomes a minus sign. So if I had 5x minus 2 squared, I'm going to do 5x squared, 5x times 5x, plus, not plus, would be minus 2 times the first term times the second term, plus 2 squared. So it's 25x squared, 2 times 5 times 2, that's 20. And then 2 times 2 is 4. Okay, so you can do it really quickly without foiling it if you memorize the pattern. And again, squaring is something we do a lot in math, so it's worth your time and effort to memorize this pattern. So if I asked you to multiply 4x squared y plus 3z, you're going to do 4x squared y times itself, so it'll be 16x to the fourth y squared. And again, the way I do it is I do the numbers. 4 times 3 is 12, double it, because it's 2ab, remember? So that'll be plus 24, and then I just attach the letters, x squared yz. and then square the last term, 9z squared, and I'm done. So that's the advantage of learning that pattern, that shortcut, squaring a binomial. And just note here that the result, if you square a binomial, that resulting trinomial you get is called a perfect square trinomial. Alright, so the next shortcut pattern we want to learn is the product of a sum and difference. Okay, so if I take two terms, a and b, and I do a sum, a plus b, and a difference, a minus b, and I multiply those out, if I FOIL it, or distribute, I'm going to get a squared, and then a times negative b, negative ab. Then I go to the second term, distribute it, plus ab, minus b squared. And notice that these cancel each other out. So you end up with just a squared minus b squared. And this result, again, we call this a difference of squares. Or difference of two squares, either way. Okay. So again, we just create the shortcut. We don't do all the work in between. We just say a plus b times a minus b is a squared minus b squared. So that's a really nice shortcut pattern. You want to memorize that also. So if I ask you to multiply 3x minus 2 times 3x plus 2, notice that both terms are the same, but one's plus, one's minus. No order doesn't matter. One's plus, one's minus. You're going to square the first term minus square the second term. So you get 9x squared minus 4. Let's try one more. So if I wanted to do 4xy minus or plus 7 times 4xy minus 7. And again, they're the same, so you just square the first term minus square the second term, and you're done. Great shortcut. Difference of squares. So the sum of a product and the product of a sum and a difference of two terms is just a difference of two squares. You square the first term minus square the second term. And that's it. Okay, I want to look at a couple of exercises in the book. So number 71, the exercise set, we get 2m minus n, 2m plus n. So you should be saying, oh, difference of squares, m minus 2n squared. Okay, so the first part, right, the result of that product is going to be a difference of squares. So you square the first term, 4m squared, minus square the second term, n squared, minus. Now, how do you square a binomial? So if you memorize the pattern, you square the first term, minus 2 times the first term times the second term. So that's going to be 4mn, and then you square the last term, so that's 4n squared. Distribute your minus sign, so we get minus m squared plus 4mn minus 4n squared. Combine like terms, so let's start with our m squares. So we got 4 minus 1, 3m squared. Let's do the mn, 4mn, and then our n squares. So we got minus 5n squared. And there we go. Okay, let's look at number 74. m plus n plus 2. Now there's two ways to do this one. We can just distribute each term in the first parenthesis with each term in the second. So like in class, typically I like to have you try this one on your own, and then I show you the second one. Typically students will do it that way, where you take the m, distribute it, take the n, distribute it, then take the 2 and distribute it, and then combine all your like terms. And then I would show you the easier way, because what I'm going to do is I'm going to view this as m plus n plus 2, m plus n minus 2, and group it that way. So the m and n, I group it, and now I think of this as this problem, a plus 2 times a minus 2. So think of the m plus n in the parentheses as that a. So tell me, if I ask you to multiply this, you say, oh, that's a different square. A squared minus 4. That's my answer. So basically the a is that m plus n. So it's a squared minus 4. And then I use my shortcut formula for the m plus n squared, which is m squared plus 2mn plus n squared minus 4. So once you master those shortcut formulas, a problem like that becomes really easy. Okay, so, I would challenge you to try to learn those formulas. Go ahead and do it the other way and just see how much time you actually save. Alright. So that got to cover one more thing. Talk about the function notation. Okay, so let's look at number 80. And again, we have this function notation for this polynomial. F of x equals x squared plus 7. And I want to find f of p plus 1. Now, if you remember our function notation, f of p plus 1, wherever I see the x, I'm going to take the x out. I'm going to put whatever's in that parentheses. So I'm going to put p plus 1 in for x. Now, so f of p plus 1, I'm going to use my shortcut for p plus 1 squared. P squared plus 2ab. A is the first term, which in this case is p. B is the second term, which in this case is 1. So it's 2 times p times 1, which is 2p. And then the second term squared would be 1 squared. And then plus the 7. So we get p squared plus 2p plus 8. Alright. Now for b, we got two parts to do. We got f of a plus h. So that's going to be equal to minus f of a. That's going to be equal to, so wherever, for f of a plus h, that's going to be x squared plus 7 minus x squared plus 7. So for the first one, a plus h, I put in a plus h for the x. For the second one, I just put in a for the x. Okay, simplify that. So I get a squared plus 2ah plus h squared plus 7 minus, now distribute the minus sign. Combine like terms. So let the a squares cancel. Plus 7 minus 7 cancel. So I just get 2ah plus h squared. A lot of students struggle with that one at first, but again, it's just learning the notation, not stressing out about it. Just plug in whatever's in the parentheses for x in the f function. So it's x squared plus 7. So you just put in the a plus h where you see the x. And then for f of a, same thing. Put in the a for x. So it's x squared plus 7, so it becomes a squared plus 7. And then just simplify it. Okay, so that concludes the lesson for 5.2. Go to my math lab and complete your exercises there, and I'll see you next time.